Today's lesson, we are going to go over how to identify the number of solutions of a linear system. So we've done a lot of practice with solving linear systems that have one solution or one point of intersection if we're graphing them. But sometimes there are some that don't work out like that. So there are some linear systems with no solution, and those can also be called an inconsistent system. And those with the no solution will graph parallel lines, as you will see. And then there are also those systems with infinitely many solutions, and these are called a dependent system. And those will have coinciding lines. So first, let's focus on those with no solution. Now remember, there's three methods to solving a linear system. There's the graphing method, the substitution method, and also the elimination or the linear combination method. So we're going to do these problems showing you how all methods can be used to identify no solution or infinitely many solutions. So first we'll focus on the problems with no solution. So here we have an example, and we're going to use the first method of graphing here. So we have two different equations. The first equation is negative 5x plus 4y equals 16, which I'm going to graph. And then the second equation, I'm just recopying them so I have some room here to get the y's by themselves, is 5x minus 4y equals 8. Now when I go to solve these, because I'm going to be graphing, I do need to get the y by itself. So first thing I'm going to do is try to get my y by itself by moving my x to the other side. So now I have 4y equals 5x plus 16, and then we divide everything by 4. So I can get it into that slope-intercept form. Y equals 5/4 x plus 4. Now the second equation, again, I'm going to go for my y by itself. So I'm moving that 5x over by subtracting it. That leaves me with negative 5x plus 8. And then I'm dividing everything by the negative 4. So y equals positive 5 over 4x minus 2. So now when I go to graph these, if I'm graphing my first equation, I'm going to begin at my y-intercept, which is 4. I'm going to move in accordance with my slope, which is 5 over 4. So I'm going to rise 5, 1, 2, 3, 4, 5, and run 4 to the right. Now, as always, if you run out of room to make points with your slope on your graph, you can go the exact opposite direction. So I could also go down 5 and 4 to the left if I need some more points to kind of finish out that line. All right, so there is the graph of my first line. Now my second line, I'm going to begin at my y-intercept of negative 2 this time. And then I'm going to move in accordance with my slope, which also happens to be 5/4 again. So again, I'm going rising up 1, 2, 3, 4, 5, and then running 4 to the right. 1, 2, 3, 4, 5, 1, 2, 3, 4. 4 down, 1, 2, 3, 4, 5, 4 to the left to get some points in the other direction. So you can see here we ended up with parallel lines, which means that there is no solution. We can't have a solution because there's no point that is on both of these lines. So remember, the point that we're looking for, the solution, would be a point of intersection or a point that's shared by both lines because it would have to work for both equations. But in this particular case, they're parallel lines. There's no shared points, no solutions here. Now, keeping in mind, the lines had the same slope. So if you'll notice, they both had the same slope, but they had different y-intercepts. So that's how we knew that this was going to happen. So whenever you have two lines with the same slope, they're going to be parallel as long as those y-intercepts are different. If they have the same y-intercept, then that's a different situation, which we'll talk about in a few minutes. All right, so let's see what this would have looked like if we use a different method other than graphing. So let's say we wanted to do this by the elimination method. Now, if you remember the elimination method, that's when we want to try to add up our two equations and get something to cancel. Now, if we look at this equation currently the way it is, and I go to try to add these up, already something is going to cancel because I have this 5x and negative 5x. So when I add those x's up, they cancel, but my y's also cancel. So I've eliminated all of my variables, and I end up with just 0 equals 24. So when this happens, this is a false statement because 0 does not equal 24. So this means that there are no solutions. And of course, if there's no solutions, that means that the lines would be parallel if we were to graph them. All right, now let's look at substitution. Now, substitution would not be my go-to method in this case, mainly because they're already set up for us in standard form, and for substitution, I would need to get one of my variables by itself. But just to show you how it could work. So I'm going to go ahead and I guess I'm going to get this variable by itself. There's really not any good options here. So I'm moving my 5x to the other side. I have negative 4y equals negative 5x plus 8 dividing by this negative 4. And you should get the same y equals that we had in our graphing problem. It's the same. All right, so now in this situation here, I have the y by itself. So I can now substitute this piece here into the y that we have not used yet. So that would be the second part of substitution. So negative 5x plus 4 times 5/4 x minus 2 equals 16. So you can clearly see why elimination is a much easier option in this problem. Now I'm distributing. 4 times 5/4, the 4's cancel, and I'm left with plus 5x minus 8. 5x and negative 5x cancel, so I have negative 8 equals 16. Once again, that is a false statement. Negative 8 does not equal 16, so this is just another way to tell us that this is no solution. So you can see all three methods were able to get you the information that you needed. However, some of them are going to be quicker or easier, shorter than others, and it's really going to be dependent on the problem. All right, so let's go on to the next page, and now we're going to look for examples where there are infinitely many solutions. That's going to look a little bit different than no solution. So in this case, we have our two equations. So my first equation is already set up for us in a y equals mx plus b, or that slope-intercept form. So I can go right ahead and graph it. So I can see here that my slope is 2/3 and my y-intercept is 5. So I'm going to start out by plotting the 5, which was that y-intercept. And now I'm going to move up 2/3. Or if I need some more points going in the other direction, I can go down 2/3. Okay. So now I'm going to go to the next equation, but this one is not set up in slope-intercept form, so I'm going to do that first. So I'm going to add my 2x over to the other side. 3y equals 2x plus 15. dividing everything by 3, y equals 2/3 x plus 5. Now notice that's the exact same equation that we had already for the other one. And I'll notice if I graph it, I begin at the 5 and then I'm going up 2/3, up 2/3. I'm ending up on all the same points. So you can see that it's going to be the same line again. So in this situation, if both of my lines are graphing through all the same points, this means that I have infinitely many solutions. And I usually just write the abbreviation IMS. And that means that my lines are coinciding. And coinciding just means that they're basically the same. They're on top of each other. They're sharing all the same points. So here, the lines that have the same slope and the same y-intercept, the solution will have infinitely many solutions. So you can see the difference there. In both parallel lines and coinciding lines, the slopes will be the same, but the difference will be whether or not they have the same or different y-intercepts. And then, of course, if they have different slopes, we know that the two lines would be intersecting and have one solution. All right, so let's see what this looks like if we use a different method. So this time, substitution method will actually be easier, whereas last time elimination method was easier. And that's because this is already set up for us with the y by itself. So it's a lot easier for me to just substitute that in. That first step's done. So all I have to do is negative 2x plus 3. Then in my parentheses, I can put in my 2/3 x plus 5 equals 15. When I distribute, the 3 times 2/3, the 3's cancel. 3 times 5 is 15. And you'll notice my x's cancel here, and I'm left with 15 equals 15. This is a true statement because 15 does equal 15. So that means infinitely many solutions. Now let's see if we did the same problem by elimination method. Well, the first thing I would have to do is put it in standard form, right? So I'd have to move that x term to the left so that it's an ax plus by equals c form. And then I'm just going to recopy the second one underneath. And then I would want to try to cancel some stuff out here, but the problem is nothing's going to cancel right now. So I'm going to multiply this first row by negative 3. That will make it positive 2x because the negative 3's will cancel. Negative 3y equals negative 15. Now, when I go to add those, right, I end up with the x's and the y's both canceling, giving me 0. But then over here, my constants also both cancel, and I get another 0. 0 equals 0 is a true statement. So since that's a true statement, this would be another example of infinitely many solutions, which means I have coinciding lines versus parallel or intersecting. All right, identifying the number of solutions without actually solving. So the last page we went over solving. We could use elimination, we could use substitution, we could also graph and see where they cross or don't cross. But actually, all we really need to do, we don't actually fully have to graph them. We could just get them into that slope-intercept form, and then we could analyze the slope and the y-intercept to see if they're going to be parallel, intersecting, or coinciding. And that would tell us if they have one solution, no solution, or infinitely many solutions. So if I'm going to do that here, so for equation 2, I'm going to move my 7x over. And that gives me negative 2y equals negative 7x minus 1. And then I have y equals positive 7 over 2x plus 1/2. Now, if I want to do this for the second equation, just so you can see the difference. Look at the difference here. The only difference is the C value. The X and the Y were exactly the same. So watch what happens with this one. If I have 7x minus 2y equals 9, I move my 7x over. Negative 2y equals negative 7x plus 9. Divide by negative 2. I end up with y equals 7 over 2x minus 9 over 2. So notice what happened. My slope stayed the same because my x and my y were both the same here. So the slope stayed the same. But because the number on the other side, the equal sign, was different, the y-intercepts were different. So this was an example of the parallel lines which have no solution, right? So really, once you kind of see those relationships in the equations, you don't even have to solve too much. Now, in this next equation, looking here, we're like, well, I have two equations, but they look pretty different. It's not like the last time where the x's and the y's were the same. So they're set up in this method. I'm going to try doing the elimination method and see what happens. Well, I'm going to have to multiply this by 2, right? Once you do that, you get 6x plus 2y equals negative 20. Now notice this time, everything's the same here, except the signs are all switched, right? So if I have a 6x and a negative 6x, a 2y and negative 2y, a negative 20 and a positive 20, I know everything is going to cancel. And I'm going to end up with 0 equals 0, which is a true statement. And that's going to mean that there's infinitely many solutions here. Now, looking at the equations, if you notice, you have everything the same, the x's, the y's, and the constants. Even if they weren't canceling out yet without multiplying by -1, you'd still be able to tell that these are really the same equation. All right, so then the examples here tell whether the linear system has no solution or infinitely many, and we're just going to do by whatever method. Now, these would be good options to do substitution since the y is already by itself, or to just get the two equations into y equals format and just kind of look at them. So I'll do both options, right? So for the first one here, I'm going to do substitution. Since this is already set up y equals, I'm going to substitute in for this y here. So I'll have negative 15x plus 3 times 5x plus 2 equals 6. I'm going to distribute to get rid of those parentheses there. So I have a plus 15x plus 6. And of course, the 15x's will cancel. 6 equals 6 is a true statement. So that tells me it's going to be IMS. Now, in the second one, I could do the same method again. I could just substitute in my y. But since this y is by itself, I'm actually going to just get the y by itself and then just kind of compare them. So if I add my 4x over, I have y equals 4x plus 5. So now look at my two equations. They both have the same slope, but they have different y-intercepts. So that tells me they are parallel lines, which means there is no solution. They will not cross or intersect. And it doesn't matter what method you use for these. You should be able to get the same conclusion regardless. So you could have done substitution again for this one, or the first one you could have got y by itself, or you could have done elimination. All right, so for this one here, we're going to do the same thing again. They may also throw in one that actually does have one solution. So let's see what happens. All right, so this one already has the x almost by itself. So one option is to solve for that x, or the other option is to just get them into standard form and do elimination. I haven't done that, so I'm going to do that method. So I'm going to move my y over. So that's going to give me 4x minus 12y equals 28. And of course, my first equation is just x minus 3y equals 7. So at this point, I'm going to multiply this first row by a 4. So I have 4x minus 12y equals 28. And now my second equation is also 4x minus 12y equals 28. Now, if you had multiplied by a -4, then you would see everything's going to cancel. Even if you don't do that, you're going to see these are exactly the same, which means the lines coincide, which means they're the same. And there's going to be infinitely many solutions. And the reason I did it that way is because it said without solving. If it said to solve it, then I would have done -4 and everything would have canceled. But you get the same idea. There's lots of ways to look at it. All right, now this next one, again, they're already set up for me in this standard form. So looking at it right now, I can't see anything that's going to cancel or whatever. It doesn't look like I can easily make these into the same equation. So that tells me that these are probably going to have one solution. And if I'm not sure, I could try to like kind of multiply by something to get them the same. I know that 2 and 3 both go into 6. So if I multiply this row by 3 and this row by 2, let's say, I get 6x plus 12y equals, and then 17 times 3, I believe, is 51. Now, let's say I did the -2 or +2. I have -6x minus 12y equals, and that would be -28. Now, look, these are going to cancel. I'm going to be left with 0 on this side, but this side I'm going to have an answer. I believe it's 14. No, 13. So this tells me this is a false statement, so there is no solution because that is false. 0 does not equal 23, so no solution. And then finally, our last one here, I'm going to use substitution this time. I'm going to get the y by itself. So y equals 4x plus 5. I'll substitute that in for my y right there. Of course, you can choose to do a different method. -14 times 4 is 56. -14 times 5 is, I believe, 70. And then here, -8 and that's going to be -64x. We're adding our 70 to the other side. We have 48. Goes into there 6 times, 8 goes into there 8, and then we can continue. So -3/4. All right, so now plugging that back into the beginning, I have -4 times -3/4 plus y equals 5. These cancel. I'm left with just the 3. And then I would subtract y equals 2. So this would tell me I have one solution, which is -3/4 and 2.